Hello everyone. In today's video, I'm going to show you how to divide a complex number. Let's get started. So before directly going to divide a complex number, I want you to understand one concept. That concept is the conjugate, okay? The conjugate, right? What is a conjugate? If we don't know the conjugate, it's going to be a little bit harder to divide a complex number. So simply a conjugate is, let's say if we have a complex number that has a form of a plus bi, as you may know, this is the formal form of complex number. So if I just simply switch the plus into minus, a minus bi, so a minus bi is the conjugate of a plus bi, or a plus bi is the conjugate of a minus bi. So basically what it means is both of them are conjugates of each other. So when you have a minus, if you switch it into plus, that's the conjugate of the minus. And then if you have the plus, if you change it into minus, that's the conjugate of the complex number. Okay, so just keep this in mind. Keep this in mind. The other important thing I want you to know is also this. Okay, I want you to know is this. So the I square is equal to -1. I square is -1, or in other words, square root of -1 is going to be just I. Okay, so these are very important concepts or very important points to know before we go to do some problems. Okay, now what's the reason we are using the conjugate? What is the reason to use the conjugate? Because this is the standard form. This is a plus bi or a minus bi is the standard form of complex number. So we don't need to have this in the denominator. Okay, we don't need this one in the denominator. What does that mean? Let's say, for example, we have this one, 3 minus I divided by 3 plus 2i plus 2i. Okay, look at this. This is dividing a complex number, but I told you that the formal form of a plus bi, okay, or a minus bi. I want to see only this form. I don't want to see 3 minus I over 2 plus 2i. So I have to eliminate the denominator by any means, okay, by any means. I have to eliminate that by any means. So to eliminate that, all I have to do is, the rule is, you have to multiply both the numerator and denominator by the conjugate of the denominator. Okay, look at this is the denominator. We have to multiply both of them by the conjugate of the denominator. What is the denominator conjugate? Which is 3 minus 2i, because you see 3 plus 2i is here. 3 minus 2i is the conjugate of that. And then both of them, okay, 3 minus 2i. Okay, now you see. So I'm going to multiply both the numerator and then denominator by the conjugate of the denominator. All right, now as always, what I have to do is I have to multiply the top with the top, the bottom with the bottom, or numerator with numerator, denominator with denominator. Okay, so what I'm gonna get, all right, 3 minus I, okay, 3 minus I, you multiply that by the conjugate of the denominator, which is 3 minus 2i in our case, right? You divide that by what? By 3 plus 2i, right, times 3 minus 2i. Okay, technically 3 minus 2i over 3 minus 2i is 1. I just multiply the whole thing by 1. That means I don't do anything, but that will help me to eliminate the bottom part or the denominator from being a complex number. Okay, because complex number, when you multiply complex number by its conjugate, you get a real number. Okay, you get a real number. I'll show you that in a moment. Okay, so let's continue now. Let's continue. So what we have to do is we have to apply the distributive property. You have to apply the distributive property, and then make sure you remember this. Okay, I square is -1, negative square root of -1 is I. Okay, so what I'm gonna do now is I multiply this with 3, distributive property, and again this with this one. All right, and the same thing is true for the bottom. So 3 times 3 is what? 3 times 3 is 9, right? And then 3 times negative 2i is -6i. Okay, and then I'm done about this 3. Go to the negative I. Negative I times 3 is -3i. Okay, and then negative I times -2i is negative times negative is positive. 2i times I is positive 2i square. Remember, I have I here, I have I here. I times I is I square. Okay, now leave it that for a moment, and then let's go to the denominator. If you go to the denominator, over, this is all over, right? This is all over. 3 times 3, as always, 3 times 3 is gonna be what? 9, right? And then another one, 3 times 2 is minus 6i, right? And again, go to the 2i, okay? 2i times 3 is this, 2i times 3 is plus positive 6i. Okay, and then 2i times the negative 2i is negative of 4i square. Okay, this is the next step. All right, now let's go squeeze if we can do something. Okay, remember now the rule. Remember the rule. The rule I have here. This one is very important rule. So let me do something. Okay, so the next step is gonna be this. Okay, look at the middle term. The middle term is minus 6i minus 3i. So they are like terms. I can combine them together. I just keep my 9 here, minus 9i. Okay, because 6i and 3i is 9i, plus, okay, 2i square. Remember 2, but I don't have to repeat I square now because I know that I square means negative 1. You see the rule, this rule, I square is negative 1. So instead of I square, I can go ahead and then plug in negative 1. Whenever I see I square, always I have to plug in by negative 1, okay? So I finish that part and then go to the denominator. Now I'm gonna go to the denominator. Do the same thing. Look, the middle term is minus 6i plus 6i. They are like terms but opposite sign. They'll cancel each other. So if they cancel each other, I remain with 9, this 9, right? And then negative, okay, 4. And then I have I square again, okay? I remember when I see I square, I have to always plug in by negative 1 because that's negative 1, okay? That's why I give you the rule at the beginning, okay? Now, the next one is this. So let me clean up my numbers. Okay, so what is 2 times negative 1 is just negative 2. So this will be further 9 minus 9i minus 2, because this is 2 times negative 1 is negative 2, divided by, look at now, this is 9 minus minus 4. Negative 4 times negative 1 is 4. 9 plus 4 is going to be 13. The bottom line is, the bottom part is 13. Okay, so this one is now 9 minus 2, because these are two numbers. 9 minus 2 is 7, right? 7 minus I, okay, 9i, sorry, minus 9i over 13, okay, over 13. Remember now, we are very close. So this is the big bar, the 13 belongs to both 7 and 9i. So I can do this further, okay, split that, 7 over 13, right, minus 9 over 13 I, okay? So look at this carefully. This is the last answer. So this has a form of, remember, your A part or the real part is 7 over 13. Okay, that looks like A minus, and then bi, which is the intended form of the complex number. So this is like this one. Look at that. Okay, so this could be plus or minus. It depends on what is in the problem. But the bottom line is you need to have the real part, which is the a, and then the complex part, which is the bi, regardless the sign plus or minus. Okay, so this is the first problem. Let's do one more problem, and then we'll see. Okay, let's do now one more problem. So the second problem could be something like this. Okay, let's say I can call this one number 2. Okay, I can call it number 2. So I have 3 plus 10i. Remember, okay, this is a plus bi. The form is correct. Okay, then over, I can have just simply 2i. All right, remember, when I have 2i, that means, in other words, this is 0 plus 2i, because that is 0 plus 2i. Okay, 0 plus 2i is just a complex number. So the real part is 0 because 0 is a real number. And then the imaginary part is the 2i. So I don't have to worry about this if there is a number or not, because 0 is a real number. Okay, the next step is, remember to multiply this by the conjugate. Okay, if you have 2i, what is the conjugate of 2i? The conjugate of 2i is negative 2i, because this is plus. So that means I have to multiply both of them by negative 2i, all right? And then another negative 2i, okay? So I have to multiply the top with the top, the bottom with the bottom. This is multiplication, how the multiplication goes. So 3 plus 10i, okay, bear with me, times 2 negative 2i, in fact, over what? Over this one, okay, 2i, right, times another negative 2i. All right, okay, excellent. Now let's go. As always, do the distributive property. Okay, 3 times negative 2 is what? 3 times negative 2 is negative 6, right? This one with this one. And then 3 times negative 2 is negative 6. And then another one is 10i minus 2i. Okay, minus 10 times 2 is what? 10 times 2 is 20 and I square. Okay, 20i square, right? Very good. So the next one is what? The next one is over, right? This is over. Let me do the bottom part as well. 2 times 2 is 4. There is negative here. Negative 4. And I times I is I square. Negative I square. Okay. Now, remember now. Remember now. So this is what I'm going to do. Well, at this point, I forget that I. Remember that one, that's I. Remember, because 3 times negative 2i is negative 6i. And then 10i times negative 2i is negative 20i square. Okay, be careful. If I forget things like that, that's going to be a mess. Okay, so let's go now. So let me keep minus 6i because I can do nothing about it, but I can change the I square by negatives, which is 20 times negative 1. Okay, because whenever I see I square, I have to change it by negative 1. Okay, you divide that one by what? Negative 4. Here is I square again. That I square has to be negative 1. Okay, now very close. Look at this now. All right, so this is negative 6i. Remember, this negative times negative is positive, plus 20, right? Positive 20. All right, it's coming over. Negative times negative is positive, which is positive 4. Okay, now the last step is going to be rearranging this in standard form. So the real part has to come first, which means 20, and then the imaginary part has to go second, minus 6i. Okay, both divide by 4. Okay, if I divide both of them by 4, 20 divided by 4 is 5, right? And then 6 divided by 4 is negative 3 over 2i. Okay, so look at that. This is the form. It has a form a minus bi. So your a is 5, your b is 3 over 2. Okay, 3 over 2. So this is just the answer, the last answer. Okay, now notice that always when we multiply one number with its conjugate, look at this one, is always a real number. Okay, if I multiply any complex number with its conjugate, it's a real number. Okay, what does that mean? Let's say that's why it's helping me always to end up a real number, to have a real number at the bottom. You see, this is 13, the real number. Again, when I come here again, I have number. Look at this one. This is 4 again when I multiply to I and negative to I. So you have to recognize that when you multiply a complex number with itself, you always get a real number. So let's say, for example, this one, look, let's multiply to 3 plus 2i, right? Always, this is always. What is the conjugate of this guy? The conjugate of that is minus 2i. You change the sign, right? All right. So let's do now. If I do 3 times 3, 3 times 3 is 9, right? 3 times 3, and then 3 times minus 2 is minus 6i, right? And then 2i times 3i is plus 6i. Okay, 2 times negative 2 is negative 4 and I square, right? Okay, look, the middle term. The middle term is always the same, but opposite sign. So you cancel that out. So I remain with 9, right? Minus 4 times, and then I square is negative 1. Okay, this will be 9, right? So negative 4 times negative 1 is 4, which is plus 4, which is equal to 13. Okay, this is the real number. So every time when you see two conjugate complex numbers and then you multiply them, you end up having a real number. Okay, I hope you enjoyed today's video. I will see you another time.